discuss about compare instructions in logical group of instructions of 8085 microprocessor. This compare instruction is similar to subtraction instruction. The only difference is that during subtraction the content of specified register or memory location is get subtracted from content of accumulator and the result was saved in accumulator and all flags are affected based on results. But in the case of compare instruction, the same operation is done, that is content of specified register or memory location or the data directly given in the instruction is get subtracted from content of accumulator, but the result is discarded. That means result is not saved in accumulator. Instead, it is used only for making the status flags activated based on the results. That is, status flags may be set or reset based on the result of this operation. Result is not saved in accumulator. That is the difference between compare instruction and subtraction instruction. The first compare instruction is CMPR. Whenever this instruction is executed, content of specified register R is get subtracted from content of accumulator. Result is not saved in accumulator. All status flags are activated, set or reset based on results. Whenever we are converting this instruction into machine code, the machine code size is 1 byte long. That is, in order to save the machine code of this instruction, it requires only one external memory location. Therefore, this instruction is a 1 byte instruction. During execution of this instruction, the first byte, that is opcode of the instruction, need to take from external memory into inside MUP, that is instruction register. That operation is opcode fetch. So in order to complete the execution of this instruction, it requires only one machine cycle, that is opcode fetch. For opcode fetch, number of t-state required is 4. Data for the operation is available in any of the general purpose registers. The addressing mode is register addressing mode. All flags are get activated, that is set or reset based on the results of this operation. Next instruction coming under this category is CMPR. Whenever this instruction is executed, content of memory location whose address is available in HL register pair is get subtracted from content of accumulator. Based on these results, status flags are activated, result is discarded, that is result is not saved in accumulator. When we are converting this instruction into machine code, the machine code size is 1 byte long. Therefore, this instruction is also a 1 byte instruction. During opcode fetch, MUP need to take that first byte, that is opcode, which is saved in external memory into instruction register. Then MUP need to read the content of memory location pointed by HL pair. That process is memory read. So in order to complete the execution of this instruction, it requires two machine cycles. One is opcode fetch and another one is memory read. So total t states to complete the execution of this instruction is 4 plus 3, 7 t states. As the address of the operand is specified in register pair, the addressing mode is register indirect addressing mode. All flags are affected. Next compare instruction is CPI data 8. Whenever this instruction is executed, the data which is directly given in the instruction is get subtracted from content of accumulator. The status flags are activated based on the results. The status flags get set or reset based on the result of this operation. But the result is discarded, that is result is not saved in accumulator. When we are converting this instruction into machine code, the machine code size is 2 byte long. Therefore, this instruction is a 2-byte instruction. Byte 1 represents opcode of the instruction and byte 2 represents this data. So byte 1 we need to save in one location, byte 2 we need to save in another location. So in order to save the machine code of this instruction, it requires two consecutive memory location. So during execution of this instruction, byte 1, that is opcode, MUP need to take into instruction register. That process is opcode fetch. Then byte 2, that is data which is available in the instruction, need to take from external memory into microprocessor. That process is memory read operation. So in order to complete the execution of this instruction, it requires two machine cycles. One is opcode fetch and another one is memory read. So total T state required to complete the execution of this instruction is 4 plus 3, which is equal to 7 T state. As the data of the operation is directly given, the addressing mode is immediate addressing mode. All flags are affected.